Hey everyone, welcome back to our channel. In today's video, we are delving into the captivating that world of data science to tackle a topic that's both intriguing and practical for employee salary prediction. Whether you are passionate about the data, navigating the job market, or just curious about how number of shape our professional lives, right? So this one's for you. We will unravel that secrets behind that salary prediction models and uncover the variables that truly impact that compensation and showcase that transformative power of data driven insights. So if you're ready to discover how data science is reshaping that way we determine the salaries, and don't forget to hit the like button and the subscribe. Let's dive into that for the employee salary prediction in data science. If you're new here, please make sure to subscribe and hit that notification bell so you never miss out the data packed exploration. So let's jump in. All right. If you are going to generating that one prediction engine in Python, so you need to create some data set. So because of the data set only, the system will know, okay, this is the sample data set looks like, and this is the output they want actually. So we need to prepare the data set for that, and after that we need to feed to that our system, that means our code, and that AI will understand and it will be returning that answers based on the data set, right? So here is my sample data set. So in that name, age, gender, and number of projects completed, and productivity, satisfaction rate, and the feedback score, department, position, joining date, and salary. So these are the things are dummy data, so I can put it all the kinds of department and position and the joining date, and based on the HR gives that rating, right? Productivity, satisfaction rate, feedback score, like that actually. So around 201, around 200, yeah, 200 data is there for the sample data set. So this one I can go to the Kaggle website and I can load that. So even you can use that Jupyter notebook, or if you don't have that Jupyter notebook, you can go to the Kaggle or Google Colab, or this kind of online Python notebooks available, so that you can use it. For my side, I can use the Kaggle. So let me open that Kaggle. All right. If you are going to, once you open the Kaggle, so after that, that home page looks like actually. So in that, you can create a code, and under the code, you can create a notebook. So after that, so you can feed your data over there. So after that, you can just call it from that Kaggle input actually. So this line, if you use that automatically, that whole data will be stored in that memory actually. So initially I can import that NumPy and the pandas. So after that I can read that my data set. So the next part I can import the record libraries. So obviously in the data science we can use the pandas and the NumPy, and for map and the diagrams and all those things. So we can use that matplotlib and the cbond and missing now, and plotly, and we can obviously ignore the warnings, and for the heat map we can use that folium. So these are the header library I can use. And the next part I can loading the data set actually. So in that I can already uploaded that my data set, so I can just upload it as a CSV, and I can just check that header, and also I can check that is anything null or anything some values there, so that I can check it actually. So if I run that, once I load the data set, I'm getting that CSV file based on that actually. So in that CSV file, as you can see uh, that all the things. Let me zoom it. Yeah. So the name, age, and project completed, joining date, salary, blah blah blah. So all those things I can get. And the next part, I'm going to check that if there is any null value, and if there is any null, and I can count the values. So can just check that. So all the fields, no null values is there, and all the types of int actually. So the next part, I'm going to check the data type of each column. So data frame.info. If I enter that, it will be simply return that each of the fields, which data type is there actually, so that it will be show. I just verified okay, name, age, gender, so all those things are the same format actually. And the next part, data frame that describe, so it will be describing that okay, so it will be returning that description, the data frame actually. So if the data frame contains the numerical data and the description contains this information for the each column count, the number of not empty value means that average, mean value, std, that standard deviation obviously. So it will be just returning that overall descriptive details actually it will be give, and with the point of values actually. And the next part, data frame equal to df dot drop name axis 1. So this code is removing that column labeled name from the data frame represented by the variable of df data frame obviously, effectively modifying the data frame. So exclude that column, and it will be modifying the data frame and it will be assigned to that same df value actually. So in that part, so we just removing that name column actually. Let me execute. So once I executed that, that next part, exploratory data analysis, that called EDA. So in that EDA level, we will deeply analyzing that data using that some by charts and a graph and a plot, like that actually. So the first part I can check the head, and so this is the head name. I'm already removed that, so I can just keep it as a male, female, number of projects, position, joining it. I keep the rest of all the things, and I can check the shape. That means the size, 200 rows and 10 columns actually, like that. So the next part I can create a KDE plot. That means that same as exploratory data analysis. So in that I can make a own plot diagram actually. So in that, SNS is a library. So in that library we already implemented that cbond actually. So we just include that cbond.kde plot, and along with the data frame in that data, so shade true, and plot GCF set size inches 6 8 and a plot equal to show. So just I making that kde plot, that's all. So after that I can just call this function for the age. So age wise it will be generating that plot actually. It may execute. So if I execute by the age, and as you can see that, so it will be generating that bar plot based on the age value actually. So above that 30 to above the 20 to 40, that 30 age, almost lot of things there actually. So along with that, the project wise I can same as kde plot. So number of projects around averagely all the persons will it take average, so around 10 to 12 around the projects they are completed actually. And obviously productivity wise also the same. So we can generating that productivity actually. So makes sense, right? So using this cbond library, so we can create a n number of diagrams based on our user data actually. The next part I can take the total number of people from the each gender. So previously we will find the productivity and the projects completed, and the age wise we can generate the charts, right? So in that I can choose that gender wise and sex wise and number wise, male or female, like that actually. So in that I can take the data frame as a gender and the value counts. So that method is called the gender column. It will be returning that series of containing the counts of unix value in that column actually. In other words, it provided a count of how many times each unique gender value appears in the column actually. So that's why we use that value counts. Yeah, and the reset index after getting the value counts as a series. So this method is called the reset index, resulting that series. By default, the index of series should be a unique gender values. So that reset index makes the index separate the column and assign the default integer index value to the series actually. So up to this point, the gender variable contains the data frame, two columns, one containing the unique gender values, other containing the corresponding counts. That's all actually. And Finally, I can return that just gender. So gender is a data frame, obviously. So the next part I can show to the bar plot. So in that I can use that px. So px comes from the ploxley library, actually ploxley library. So in that ploxley px dot bar, in that I can mention the total salary along with that sex and the salary color of sex. So if I do that, let me show. So the female salary total and the male salary total, after that they is classified, and based on that bar plot will show. Yeah. So in that as you can see that female getting that more salary compared with that men, actually. So that's why. And the next part, average salary earned by the each gender, actually. So that we need to find out, and in that part I can find out that mean salary. So for the mean salary I can just group by the gender, and in that gender I can get the salary. Based on the salary, reset in the index same as. And I can same as I can split out that sex and the salary, male how much and a female how much, like that, actually. So in that, as you can see that male, female, that 76,985, and a male should be a 76,253. And if you see in the result in the chart, so obviously female should be a higher average salary, actually. And that next case, project completed versus salary, actually. So in that let me run that same px scatter plot. So in that, project completed versus salary by gender. So as you can see that the red dots are female, blue dots are male. So if you hover that each of the dots, so based on that, based on the salary wise, so the project should be a completed, actually. So that's why it's project completed with a salary. And as the number of projects will be complete, and at the same time income also will it gets increased, actually. And the next part, productivity versus salary. So same as I can just use a scatter plot and the productivity with the salary by gender. So I can just execute that. If you see that productivity wise, number of productivity increase, that salary also will it get increased by the gender wise, actually. So if you hover that, as you can see that each number of thing, so how much productivity, 61% and 45%, like that, actually. So, and the next part, satisfaction rate versus salary, actually. So in that I can use that same satisfaction rate with the salary by gender. So if I execute that, same as, so based on that satisfaction will it increase, salary also will it get increase, actually. And obviously as you can see that uh, if I hover that gender, female satisfaction rate 97, salary should be a 35,000. And if I just come to the male section, and the satisfaction rate should be a 94, salary also should be a 34. And as you can see the top of the thing, if satisfaction rate is 96, so 1,17,000 will be a salary. So same as we can easily to understand that data. So that's why data eda will do, actually. And the next part, feedback score with the salary, actually. So in that same as if feedback score is increased, salary also get increase, actually. So if feedback, if it is low, salary also will get low, actually. And that next part, finding the top position, actually. So in that I can just take the top position as a position, and a salary, and a mean method, and a plot wise pie chart. In that the first that string concatenation I can just use it that. So if I enter that, so automatically junior developer 11 percentage, manager 24, that means the salary wise, actually. Analyst will it get thing, and a team leader 22, senior developer 19, like that, actually. So we can easily to understand that position wise how much of salary will acquire that push for employee, actually. So in that part, manager with the team lead which have the highest average salary, so that we can calculate. So in that part, jobs equal to data frame dot group by we using, right? So in that we can create a bar plot displaying the information, that job positioning, that corresponding total salaries. And in that part we can just take that grouping that position in the data frame. After that I can take that sum of salary, and I just resetting that index actually. So the next line, top six jobs equal to jobs equal to NL or GST actually. So in that part, there is a six rows from the jobs data frame based on the values in the salary column. It keeps the rows with the highest salaries actually. And that next thing, that now the top six jobs data frame containing the information, the top six job positioning with the highest salaries actually. So in that part I can apply that bar charts actually. So in that bar charts I can choose the top six jobs with the position, salary, and the color of position, and some of the basic things I can put like color discrete. So in that color discrete level, set of color palette using that Viridri's color sequence for the plot to express actually. And the final thing, fig. So once the bar is generated, so in that bar value will be placed in that fig variable. So that fig, what it do is, so this function, that fig update layout, this function used to update the various aspects the plot's layout actually. And inside that title text, and set the title of the plot and the x-axis position. So it sets a label of x-axis, and it set the label of y-axis for the x and y axis actually. So in that part, position, salary, I just name that xy. And the finally I can show that fig dot show. So if I run that code, so automatically the top six position will be shown over there actually. So manager will get the highest pay, and the next team lead, and a senior developer, and analyst, and a junior, and the intern. So like that actually. So from here we can say that manager's highest salary, so manager is the highest salary on that part actually. So that next part, top six average jobs actually, average salary jobs actually. So in that, in position, same as I can do that. I just grouping that position, salary, and I can get the top six jobs. Along with that I can use that same techniques, but in that part I can take that the top six jobs along with that x-axis, y-axis, and in that I can just show that fig actually. So in that if I run that, so as you can see that same as manager, team lead, senior developer. So that means the manager have the highest mean salary. And the next part, number of people of different position actually. So in that I can same as in the data frame I can take the position with the counting the value and resetting that data frame index. And it will be returning that position with how many numbers of position is there. So if I run that, so manager is a 40 position, junior developer is a 35, analyst should be 33, and so on and so on. So the next part I can show that bar diagram. So based on the number count, manager should be a 40, and junior developer should be a 35, analyst should be a 33, 32, 30, and so on. And analyze the male, so male actually, how many males are there, how many females are there actually. So in that part if I execute that, so it will be returning that only male values actually. And after that I can just grouping that male position along with that salary, and I can take that top 10 jobs. So in the top 10 jobs I can total salary of top 10 jobs for males. If I run that, so automatically manager should be a high 2 million, and the team lead, analyst. So this data only for males actually, female will come down. And the next part, I can count that average salary of top 10 jobs for males actually. So if I run that, same as manager, team lead, and junior intern developer. So this is a sample data set, that's why we can put the just a limited number of things. But if you're real time, you will get that more and more data, so you can just enjoy with the data actually. So the next part, I can just counting that position again. So once I counted that, it will be returning that female related things. So same as in female level analyst should be a 21, manager just 18, and junior, and so on and so on. Team lead should be a 14. And in that part analysis of female, so in that female, it will be returning that just a female data only. So same as what we did in the male, so same code, same thing. So just we just in that place only we change data frame equal to gender equal to female. So now we have a female data, so we can run the same code again. So after that, you will get the total salary of top 10 jobs for females. So obviously manager should be a high, and this one for average thing. So average salary for top 10 jobs for females. And the next part, count data position, that position wise and number wise, same as manager should be a 22, junior person 90. And if I run with the bar charts, so that same as what we get in the result in the table format, that we can get it in the chart format actually. And the next part, finding the top departments actually. So department wise I can categorize the department and the salary wise. So grouping the department and the salary, finding the mean value with the plotting with the pie charts with the string handling. So if I run that, HR should be a 90 percentage, and finance should be a 20, sales should be 90. So based on that, it will be splitted. And in that top salary of top department, obviously, so it's loading actually. Yeah. So along with that, finance should be a highest. Oh, sorry, sales should be a highest. Finance should be a next one, and HR and IT and marketing. So these are the things are top salary of top department actually. So the next part, average salary of top 10 department. So finance should be a average salary of highest thing actually. And I can just count that department wise. So sales 47, marketing 42, finance 41. So that same count I can show from the bar charts actually. So if you see that uh, that same what we get it in the table format, so I can just transform with visualization with the power of uh, Seaborn and the matplotlib, like that actually. And that next part, analysis of mails from different department actually. So first I can just filter out that mails, and tap salary of top 10 department of mails. So in that I can just change the department and the salary. Rest of the codes are same actually. So in that I can just execute, and as you can see that finance should be highest, and average salary of top 5 department same as I can just simply change the department and 5, and that nl argct, so that just salary. And if I execute that, it will be returning that salary of top 5 departments for mail actually. So the next part, HR and IT have the highest mean salary actually. The next part I can just again counting the department with the number wise actually. So finance should be a 24, IT should be a 22, HR should be a 30, like that. And I can just compare with that by chart, same as result with I just visualization did. And just now we did in that male wise, so same as we can do in that female wise. So I can just simply execute. So rest of the codes all are same, so we can so much we will get to enjoy from this data actually. So I can count that same as, and so as you can see that, so it will be just returning that table, marketing how much, and sales hr female count wise actually. So marketing and sales have the highest female candidates actually. The next part I can use the box plots. So in that you can just execute the data frame head. So in that it's a common data frame. So male and female, all these things there up to 200. So after that I can just store that plotly express dot box. department wise, with the salary, with the color of gender, and a dark mode like that actually. So if I execute that, so after that, as you can see that, so that plotly express, so that box level graph it will be creating slightly that trading view actually. So in that, as you can see that, uh, so in that, so marketing lower funds, medium and upper funds, so all those things it will be generating like that actually. So based on the male and the female wise, so it crazy thing. And the next part, I can print as a position wise, position with a salary, color of gender wise actually. So if you see that analyst level, that maximum, that female will get 73,000, and a male will get that 74,000 like that actually, that position with the salary wise. And the same as position with the salary with the department color, not a male and a female like that actually. So in that, marketing, IT, sales, HR, finance is there. So in that, all the maps should be uh, configurable. So if you see that, salary with the position with the marketing, IT, all those things, so these are the things are just highly configurable. So what are the things you need, so just you can enable it and you can see that data qualities actually. Under that cross tab, so in that cross tab, if you see that, yeah, so department and the position with the salary wise, so it will be returning that accurate number of that salary values actually. So junior developer will get that 50,000 and 54,000 like that actually. And that next part, and in that YOJ, so that initialize the empty list, YOJ will store as a year of joining values. And the next line I can use, I can just put that for I in data frame joining data of string split of hyphen. This loop iterates through the each entry in the joining date column of the data frame df. It uses that string split hyphen method. So it split the date string using that hyphen separator, resulting that list of containing year, month and day. And inside that, I can use that int I of 22. So this conditional statement checks that if second element of the split date is less than 22. At the same as, if it is condition is true, will it get append with the 20. So that means if the month is less than 22, it means the year of joining 21st century. In that case, it appends that exact year actually over list. Else if month is 22 or greater, it means the year of joining is 20th century. So at the time, year of joining append 19th and string of 1, in this case append the following extracted year from the year of joining list. So this code is joining date entry data frame, extract the year component, determine that year of joining should be a 20th or 21st century in the month, then construct the list year of joining, calculated the year of joining values actually. So let me execute that. So after that, I can create a series with the joining date. So this one, and year of joining should be at 2020, 99, 17, 2005 actually. So after that, I can create that year wise with the total salary with the thing actually. So 1922, 41,000, 4 lakhs 14,000 like that actually. So each year to how much total salary we give actually to the employers actually. So that we can record it, and we can create a chat as well actually. So based on that year, it will be that graph will be drawn actually. So and the next part, we can just again go back with that data frame with the info and joining date. So I can convert as a int type actually. So once it's done, so the next part, converting the categorical to numerical. So in that part, I can use that scikit-learn with pre-processing techniques actually. So in that, some kind of machine learning things will come to this, and yeah, we'll see. So that preprocessing dot label encoder. So in this line creates the instance of label encoder class from the preprocessing module. That label encoder class is used for the encoding categorical labels with the integer values. It is commonly used to convert that categorical values into a numerical format, and a machine learning algorithm can work with that actually. So that's why we can use as a label encoder. And the next part and the next part, data frame gender, label encoder dot fit transform in the gender. So df dot gender access that gender column in the data frame, and label encoder fit transform of gender, right? So the fit transform method, that label encoder object, right? So label encoder applied to the gender column. So this method first fits the encoder to the unique value in the gender column, and then transforms those values into the corresponding integer labels. For example, gender column had a values male and female. Fit transform would be map male equal to 0, female to 1 actually. So that's why. And the next line, gender dot unique, right? So this method called a gender column remove that unique values represent in that column after the transformation. So that's why. And let me execute that. Yeah, so as you can see that 1 and 0, and the same as department wise we have a multiple department. So in that, if I execute that, each department have that one unique map value actually. And position wise also the same. And the next part, I can use that cbond. So in that I can generate the heat map with that correlation heat map along with that this data structures. So if I execute that, as you can see that age wise and gender and project completed feedback score. So based on that mapping value, so it will be creating a one correlation map actually. So this is how it will be work. And let me expand it. Hold on. Yeah, so as you can see that, so salary wise, so age wise, salary wise, the color should be a vary actually. So this is why heat map will generate. And the next part we can just check with that header. So the rest of the values should be the same. And this is the categorical to numerical. So now we converted as a categorical to numerical methods. And the next part using that standard scalar actually. So in that standard scalar, so in that standard scalar, so from scikit-learn preprocessing import the standard scalar. So this line import that standard scalar obviously. And first thing we can create a instance, that standard scalar instance actually. So after that I can take that salary, and I can then applies that fit transform method with that standard scalar object. So the method first calculate the mean and a standard deviation of the salary column, then transform the values using that standardization formula. Standardized value, obviously original value minus mean divided by the standard deviation. So the result should be transformed array of standardized values, which is the assigned back to the salary column in that data frame actually. So let me execute that. So after that, I can just execute that data frame dot head. And so obviously that salary wise, it will be applying that scalar thing, that fit transfer method is applied. So after that, I can start that train test split method actually. So this is a kind of model training part. So the train test split function from the scikit-learn library split a dataset into a training and a testing subsets for the machine learning. This process is essential for evaluating the performance of your machine learning model. And so the first line from scikit-learn model selection train test split actually. So we can take that train test split module from the model selection of scikit-learn. So after that I can take the salary, I can just drop it. And so after that, this create a new series actually. Why? Containing that salary column values from the original data frame of df. This is the target variable that you want to predict it, right? So the next part, x train and x test, y train, y test. And inside that I can pass that x, y and the train size and a random state like that actually. So in that part, so in that train test splitter, so under that xy train size and random state we pass that, right? So in that x is the features or input data, and y is the target variable. Train size that specified 70 percentage of data should be used to the training and 30 percentage for testing. And that random state ensure that reproducibility, that same seed will generate that same random split for every time actually. And that important thing, x train x test, y test, it's a subset actually. X train, that training feature, x test testing feature, y train target values corresponding to the training data, y test targeting value corresponding to the testing data actually. So that is why we use this method. And let me execute this function, and after that I can just execute that train head and y train head also. So it will be returning that some of the values for that. And the next part, we already built that machine learning model, right? So in that I can apply that linear regression. So in that linear regression model, I can create a own instance with a linear regression class. So after that, from the linear regression, I just apply that fitting the model for the x train and the y train. That means the input and the targeting training variable. So if I execute that, so now that linear execution completed, and after that, I can create the uh, sorry. So in that, from skill and matrices, import that mean, squared error, and R2 score. So this functions comes from the matrices module. So this function is used to evaluate that matrices for the regression models actually. And y prediction equal to model dot predict x test. So this line uses a trained machine learning model make a prediction on the testing features called x test. That predict method takes the testing feature as input and return that predicted values based on the trained model. After this line of code, y prediction, that means the y pred variable will contain the predicted value of the target variables. In this case, likely salary based on the input feature test in the testing set actually. So let me execute that, and after that I can print that y prediction. So it will be returning that some of the salary list. And after that I can calculate that mean squared error actually, so like that. So in that part, in that part, MSE equal to mean squared error. So in that y test and y prediction, I just passed over there. So this line calculates that mean squared error MSE between the true target value of y test. So under the predicted target value as y prediction, so MSE measures that average square difference between the predicted and actual values, providing that insight into the model accuracy. And the next line, R2 equal to R2 score, y test and y prediction. So this line calculates that R squared, that means the R2 score between the true target values, y test, and the predicted target values, y prediction, that means the y pred. That R2 score qualifies that proportion of the variance in the independent variable of the target that is predicted from that independent variable, that means the features. It provides that indication of how well the model fits the data compared to a simple mean based model actually. So finally I can return that MSC and R2. So I can just return it. So after that, let me run that code first. So it will be returning that two thing, that means the MSC squared error along with that R2, that means that coefficient of determination. So the next part I can just show that scatter plot of actual and predicted salaries actually. So in that I can put at that y test and the y prediction, along with that I can put that actual data. So let me run. So here is the thing, and in that actual versus predicted salary, and also I can run that this line. So this is the actual and predicted salary, red and blue. So in that part, it's not accurate, but it's almost slightly. Some of the places should be a similar, but some of the places should be a vary. And so this is the linear regression algorithm. So the next part, random forest regressor actually. So this is also a kind of machine learning algorithm. So I can import that scikit-learn in that assemble module. So in that I can import that random forest regressor actually. So after that I can create that RF model with that means random forest regression model with n estimator 500 and random state 420. So this line initializes that random forest regression model named RF model. It configured with that parameter actually n estimator and a random state. So n estimator specify that number of decision trees in the forest in case there will be a 500 trees actually. Random state it set the random seed of reproducibility actually. And the next part fitting that x train and y train. So targeting values that mean the training feature x train and a target value as y train. And random forest y prediction equal to and random for RF model predict x test actually. So this line trained model to make prediction on the testing feature of x test, predict the method generated that predicted target value based on the ensemble that decision trees actually. And in the meantime what we do in that linear regression, so same as we can calculate that mean squared error with the y test and r of y pred. So it will return that predicted target values actually. And also I can calculate that score of r of r2 actually. So that means the r squared r2 score between the true target values y test and the predicted target value r of y pred. So generated by the random forest regressor. And finally I can return the both things. So if I execute that so after it will be returned some of the things, I can put it the same actual salary which is predicted salary. So same as, so it will be almost should be a same. And I can put it in that plotting diagram. So see, compare with the linear, so this random forest regressor it should be a almost similar. Few of the things should be a difference but almost it should be a fitted. And and the next part get feature of importance in that random forest model actually. So in the first line, importance equal to RF model feature of importances. So this line retrieves that importances from the trained random forest regressor model. That means the RF model that feature importance attribute store that importance score of each feature of dataset actually. And I can import that pandas. And so in that part I can create a own data frame. So one is feature inside the data frame I can create a two columns with feature of x columns and importance of importances actually. And the next part importance as df equal to importance as df dot sort values. So this line sorts that importance data frame in descending order based on the importance column. This line sort of feature by their importance scores from the most important least and to the least important actually. So this is how in that part after that I can generate that from the cbon 2 I can generate the bar plot. So if I executed that as you can see that position wise and satisfaction rate wise it will be generating some of the things actually. And the next part I can include that xgb regressor method also in that part. So already we saw that linear regressor and forestry regression like that, right? So along with that XGB regressor, this is also comes under the machine learning one of the module. So it's come from the XG Boost and so XG Boost library. So it will be predicting the model RF model and calculate that evaluation of the matrices from the XG Boost model. And so in that part same as we what we did in that, so same estimator and a random state and fitting the model, predict the model and calculate the mean squared error and calculate that r2 score and returning that r2f2 same what we did in that previous what we did in that linear regressor and sorry that next one random forest regressor like that, sorry my bad. So these are the same kind of approach, only regressor logic will be changed, otherwise all the things would be the same. Let me run it, and same as I can run that diagram, that means the plot. So let me run with the actual with the fitted values by the price. So this is also quite similar, and almost we predicted nearby. And so the next part, very much important thing, decision tree regressor actually. So in the decision tree regressor, and this is comes from the cyclic learn. This is also one of the machine learning model, but in that currently we can use multiple kind of models at the same time, linear and a decision tree and a random forest regressor, like that actually. So in that part, result should be a, this is the result how we going to get model name, mean absolute error MAE, and map, and MSC, and root mean square error, and R to score. So in that, we can just simply loop that, but the rest of the code should be a same, and model should be a that linear, decision tree, random forest regressor, like that. So we can just loop one by one, and so after that we will get that various results from the model. So let me clearly explain the loop actually. So this one is mainly a main thing actually, that's why. So this loop iterates that over each model in that model list for each model. So for example, this model is fitted to the train data, and a prediction are made to the test set that called X test, and mean absolute error, and mean absolute percentage error, and mean squared error, and root mean squared error, and r square, r2 square, r square obviously. So scores are calculated using that predictor and actual target values, and after that I can put all the values to the one data frame called results. So then I can just return that results actually. So let me execute, and we execute, so it's completed. So after that I can return the head. So if you see that mean absolute error, and mean absolute percentage error, and mean squared error, and root mean squared error, and r squared, so all those predicted values there, actually percentage values there. And in that next part we can simply start that bar charts actually. So model name versus MAE, that means mean absolute error actually. So in that part, linear regression will be performed well, and that next part, model name is with mean absolute percentage map actually. So in that part, same linear regression, uh, its highest thing, and that next part, model name is as mean squared error. So in that same as, so mean squared error count should be a higher in that linear regression thing actually. And I can put that model name with root mean squared error, that means the RMSE. So in that also, uh, linear regressor should be a high, and a decision tree regressor is middle, and a random forest regressor is low. And the same as that next part, model name with R2 score. So random forest regressor, it should be a high compared with that linear and decision tree. So we need that mainly that auto score. So if we get a good auto score, that model will be slightly perform well in that part actually. So this is how the data scientists will they do actually. So most of the data engineers and the data scientists and data analytics, so all those things they will involve this kind of things only frequently. This is the some of the half of the stage, but still lot of concepts and things there actually. So first you can get this knowledge from this video, so after that you can just gain one by one in future actually. So hope you guys you really like that video, and if you really like that video, please subscribe my channel for more videos like this in the future. We'll see you on the next video. Bye. We hope you found this video informative and helpful. If you did, please hit the like button and consider to subscribe our channel for more videos like this in the future. Also, don't forget to share this video with your friends and colleagues who might find it useful. If you have any questions or comments, please leave them in the comment section below. and we'll be happy to respond. Thank you for watching. We'll see you on the next video.